Hello everyone, this is Kaihua Zhang from Group Sign F. Today I'm going to talk about our project, the system of waste recycling for water heating. The first part is introduction. So Sydney is Australia's largest and the most popular city. But Sydney's electricity bills have been rising in recent years. According to Statista, the CPI, which is Consumer Price Index of electricity in Australia, rose by 117% from 2008 to 2018. A large city also produces a huge amount of urban garbage. So we designed a system to solve those two problems at the same time. And the system is called waste recycling for water heating. So the waste power generation is environmental friendly way. This is based on the requirements of our clients. The advantage of our system is it doesn't require high waste disposal technology, and the overall cost is low, and it can reduce the necessary household energy cost in Sydney. So after the introduction, I'm going to talk about the in-scope work and the implement plan. So our system is unique for different buildings. Before we start the design, we have to listen the requirements of our clients. And we are going to design the tanks, container, and incinerator. Then we are going to transport and arrangement the tanks, the incinerator, the waste collector, and the container. The next part is the erection of piping. We also have to adjust the new piping to the original pipeline. The test running of the WWH system is necessary, and after the test, it is ready to delivery. And here is the financial budget. As you can see, the most expensive part of the system is the advanced version of incinerator. The picture is over here. It is designed and produced by a Japanese company called Chuwa Star. The system has two tanks. One is hot water, another one is for the cold water. Both of them are 2020 gallons. The system also has a dust collector for ash removal and a waste gas absorption tower. The sound insulation is for avoiding the noise. As you can see, the total amount of money for the system is $34,534, but it is designed for a capacity of 24 apartments. So each household only have to pay $1,439. So based on the requirements of our clients, the system has to be environmental sustainable. So why it is sustainable? Because the waste to heat is also known as bioenergy. This has been widely applied in many countries, such as East Asian and American. And the logic of the system is very simple. Rubbish is burning at high temperature to generate heat energy to hot water system. Our system could significantly reduce the stress in sustainable electricity supply in Australia, as it produced the heat that hot water system required in residential apartments. So the next part is about risk, and here comes our group member Huan Jiezhao.
Hello everyone, my name is Zhao Huanjie and you can call me Huanjie. I'm in the group of Science NAF. I'm very glad to introduce the rest two parts of our system to you. So let's start. As you can see, the first part's name is enhancement and optimizing, and we also call it as out-of-scope work. The first section in that is flue gas. We focus on it because in the process of our system, it contains a process of garbage burning. In this process, a large amount of dust will be produced. And also, in this process, our system will climb to a very high level of temperature. So this requires the purification tower of the system to have the ability to handling dusty gas. And also, it should be heat resisting. So that's why we focus on it. And the second point is noise. Well, in the process of our system, the burning and the boiling processes will both produce annoying noise. So in case of the bothering to other people, we think it is necessary to use the deadening materials to make something like walls to isolate our devices from other buildings, and also to apply this kind of materials on the floor of the roof layer. So the residents who are living on the top layer will be also cared. And the third section is incineration residue. This is because although the garbage was sent into our system already classified or something, but there are still always some garbage which are toxic or just not flammable. That's the reason why we think the ashes out of our system still need to be to be processed in some certain standards. So we need some dedicated collectors to collect this garbage, the ashes, for temporary. And we also need a periodic transporter to move these ashes away to the corresponding places. By the way, it also produces a new job, maybe. And also we think there's an optimizing thinking, which is to use the marsh gas to replace diesel oil, which can be more eco-friendly. Actually, we mean to use the garbage to produce the marsh gas to replace diesel oil. So obviously it will create lower consumption of fossil fuel, and it has less green gas emission, which are two main advantages than the method of using diesel oil. So it's just a suggestion. If it's possible, we think we should use this. So let's get into the second part, which is troubleshooting. It is mainly talking about countermeasures for risks. The first section is water leak. Well, This is because we settled two very large tanks for cold water and hot water, respectively, on the top of the building. So once the water is leaking, it can be very dangerous because it can damage the roof structure. And the waterproof roof can solve it effectively. And another point is smell leak. We're not talking about the smell which is from the original garbage, but we are talking about the smoke, something like that, which is harmful for people's health. I think we should use some devices to process it, such as a solid filter or smoke filter, dust filter, something like that, to handle it and purify it. The third part is heat insulation. As we talked before, our system can produce a very large amount of energy of heat. So it can be harmful for the equipment sometimes. So if it's possible, we think we need to use the thermal protective materials to isolate our devices from each other, if it's possible. This is for our equipment. And on the other hand, we also considered about the residents, because it's also for top layer residents, because if the heat power is produced, the people who are living on the top layer might feel very hot, so it may cause a bad feeling and even cause some extra cost of air conditioner using. So the necessary measures should be taken. The fourth section is garbage classification. It is not for something about recycling, but for safety. This is because sometimes people just throw their garbage away without the caring about the notification of classification. So sometimes some hazardous waste can be just found in the garbage boxes. In our system, it can be very dangerous if the waste can be burnt. Some flammable waste which are liquid or even air. It can be explosive. So in this consideration, some other kinds of garbage like lighters and even fireworks are very dangerous if they are put into this system. That's what we are caring about. So until now, we introduced the basic principle, the implementation, and also some troubleshooting for the system of waste recycling for water heating. That's all of our proposal. I hope you can like it. Thank you for watching.